Hello everyone, I'm inviting you to discuss my version of in-memory database design where we can talk about the code, the design, and also I prepared the tests as I mentioned in my article on my website blog. So let's start from the beginning as we talked in my article. The smallest part of the database is of course row. So we have this class here opened. This class have ID, its ID, its key value map, its hash map where we do store any data of the database. Also we have created at and updated at parameters where we do store the data of the creation or update date of the of our data. This both parameters are long data type because we will just store timestamp, not any date classes or objects. We just store timestamp. It is the best and the fastest way to compare after data. So key value map also we can set value and get any value by key, and also we can get all map using this set key value map method or separate get column and set column. You see those methods here. The row is a part of table, but before we go to table, I must mention that we have here no column exception. This is for showing the interviewer that we currently know and use a custom exceptions in our daily basis work, because it's a good tone of programming. And I will drop this exception actually in this case when somebody wants to get the column which does not exist in fact. Let's see how this exception is just a simple no column exception, how this exception looks like. So we'll just throw a new column exception with message no column and saying which one column does not exist. So let's go to the table. The table class is bigger and it have rows, name, created at and updated at. I aware you that this is just a design, so it's not the real product we are building. This is just only design. So you may say, oh, okay, let's where is some other fields? But no, it's simple design. So hold on. You will not be able to realize all the stuff of database on the interview, which lasts, for example, 2 hours. All I'm showing you here is not fitable in 2 hours also. It's much more time needed to code all the stuff, but knowing the idea, you can show to interviewer the main things you want to present, the main skills you have, and this is the main values of the, in fact, interview. So we have her name, rows, and transactions, and created at, updated at. Transactions is a hash map, and we will be doing transactions like transaction in transaction, so we can have 2 or more open transactions, and we can roll back them one by one. The latest one and next again latest one will show you all everything on the tests. I put here generate row ID. It's just simple method that generates ID for our purposes. Of course, getters and setters, I'm not mentioning about these methods in here. The table have insert, select, update, and delete row methods, so we can just create or insert or update or delete. Also, we can count rows by k. So if we want to find how many rows have this k, or we can count rows by value. We can find how many rows are in our table containing the value. Also, as I mentioned, start transaction, commit transaction, rollback transaction, and getters and setters. Also, you may mention get rows. It's like common methods. You will not be needed to use this method. Okay, the table is part of database, of course. So here we have our database class. Our database have its name, and it's as in previous table class, it's an identifier of the objects. Also, we have hash map of tables. Also, we have created at, updated at, and I must mention that name and created at are final, because created date cannot change. If we created database in this moment can be changed in future. That's why we use final. And also the name of the database in my case uh, is not changeable. So if we are going to implement database changing name functionality, then we probably need to just to do the copy of the database with another name, and this name is in fact not changeable. Here we can create, remove database, get tables, or get tables is for listing tables. Get table is just to get separate table. Also getters and setters as in other classes also. So database implements serializable class, and this is for storing database state and restoring database state from some storage, not in memory storage, just some hard drive or other storage. And this mechanism is normal and required mechanism in this kind of systems, like because we can have some power outage or server restart, for example, and we just need this is must-have functionality to bring up to work our database again. Of course, a database has its database manager, and this is it has databases hash map. We can create database, delete database, use database, and save database state to the files, which I mentioned before, and restore database state from the disk. I'm using here file output stream and object output streams, and to restore I'm using file input and and object input strings. Okay, so as we have all this stuff done, we can go to tests and verify if we did everything okay. I have here my databases tests, and let's start from the simplest row test. It's of course unit tests, and I have before each run a method which defines me a new row with some ID and with some empty hash map. After that, I have set column value test where I'm setting a new column A and its value is 10. And after that, I'm asserting that A is getting row column value. Sorry, I'm getting it's equal to 10. In fact, if I'm getting a non-existent column, then I should assert that 1 is not 0, so this test will not go on and it's just fail. The next is get column value test, and here we are trying uh, to get column A, which is not existing in this way. That's why here we are setting that 1 is equal to 1 in exception, so it's correct. Also, in this case, also we are going set A column to 10, and then assert that column A is equal to 10. Let's go forward, and the next is table test. Table test also have some before each test, which this method prepares us a table, a new table, and here I'm testing insert row where I have data A and data B hash maps, and I'm inserting into the table the rows, and it's not empty response. Next is select row by ID test, and here I'm putting data A to insert in fact row, and after I'm trying to get select that row, and it should be row instance of row class. The next is I'm trying to get not existing row ID, and I'll get null in return. Next is update row by ID test, where I have a test of putting initially data A into table, inserting row. After that, I'm updating data A to 20, and I'm asserting that my update operation, update row is okay, is true. And after that, I'm checking if the value was properly assigned and getting column value A, and it should be equal to 20, and it's okay. It's then it's pass. But in other way, if this column doesn't exist, I will try to assert 1 to 0, and of course this test will fail, which is just okay situation for us. And also we can just try to update row, not existing row, and the return with be false, which is we are going to assert. Deleting row the same, we are going to delete a not existing row, and it's false in return. And also inserting some data A row, enter the row, and after that asserting that it's true to delete. Next, we are going to count rows by k, and you see we have two hash maps, A and B, where both have has some same A k and different values, and we're going calculate how many rows we have of A, and in this first we have 0 because we didn't insert a row. After that we inserted row with data A, and we have one AK in our table. After that we are inserting row with data B, which also contains A, and now we have 2 count. After that we are going to delete one row, and our assertion is going to be 1 of count rows. After that we have count rows by value test. It's pretty similar, but counting rows by value, and here we have 0, 1, 2, and again 1 after deleting one of the rows. Starting transactions, in fact we're going to start transaction, and if it started okay, we're asserting that's true. Committing transaction, we can try to commit a transaction without started transaction, and in this case we should have false. We can try start double transaction, so transaction in transaction, and after we are going to commit one once again, and third time is false, and it's okay because we don't have any opened transactions in so many times, only 2 times. Rolling back transaction, again we're trying to roll back not existing transaction, so we have false here. After that we are starting transaction, roll back in, and it's true. Starting 2 times transaction, committing 1 transaction, so only 1 will left, rolling back the transaction, and rolling back once again, which gives us false. We will get back to transactions in our integration test. I'll show you later, and let's just move forward to our database tests as the next class. Database will also have some before each test method which creates for us a database, and create, remove, get table, and get tables tests, which create a table and it's true, and it gets to verify, it gets the table, and it should be instance of the table class. The remove will be false if we are going to remove a not existing table, and also we create this table and try again, remove, so it's okay, it's going to true. Get table test, we don't have any table that after that we are going to create some table, and after get this table, and it should be instance of table in fact. After that we are going to make get tables, and it's empty of course, and we are verifying if it's true. And then we are creating tables A, B, and C, and after that we are going to check if get tables return size and it's equal to 3, because we have 3 tables created. After that we are going to check if our new table B is in the get tables map. And it's true, it should be true. Let's check if our database manager is working okay. And here we have before each, of course, database manager creating, and after we're going to create database, new database, and it's true should be. After we are going to delete database, not existing database in fact, and it's false should return. After that we have to create database and try to delete this database again, and it should return true. Use database, and it's no, because we don't have any database, and that method just returns us no in this case, so it's okay. Create database, use database, and it should be instance of database class. Also, we should test if our save db state is working, is returning in fact true and not throwing any exceptions and so on. And we see that we are trying to save the database state with empty databases, and it should be okay, as well as creating any database and saving database state again also should be true. Restoring empty database is true, because if we don't have anything, it should not fail, just go and doesn't do any restores. After that, we are trying to create database, save database state, and after that restore, and it should go to true. And the most interesting is integration test, where I prepared for you. This test is going to do all the stuff. So it will create new database manager. It will create new database which called my test database, my test DB, and we're going select to use this database. We are going to create in this database table A, and that table is an TBL variable. Also, we have two hash maps. One hash map with data which contains KA and value 10, and second data B hash map has also KA but value is 20. And we are going to run transaction test as all units tests before were done okay and were pretty similar to assigning and getting data and deleting or updating. And here is time to make one bigger test, entire test of entire our database if it's worked. So we're going to start transaction, insert row with data A, in fact A10, and assert that our column A have in our row have value 10. After that, we're going to start transaction again, update that row with data B. So we're going to set KA to 20. And after that, we are going to assert that our column value A is 20. After that, we are trying to make rollback transaction, and rollback transaction of this one, in fact. So we should get back to 10. And after rollback, we're checking if our column value A is 10. In fact, what it is what we are expecting. So rolling back transaction again should give us null, because it will get back us to state before this transaction. where this first one transaction started, and it should be null. In case of any no column exceptions and so on, which is not expected here, we will asset 1 to 0, so this test will not pass. In case of any troubles, so let's try it. So I'm going to use Maven and just run nvn test here, and we are going through the tests. We have test run 22, failures 0, errors 0, and skip 0. I have here some even outputs because of no open transaction exists, and deleting row, updating row. It's useful if we want to have any type of logs or something. I'm committing this code, this tests code to my repository just now, and already you saw the message of commit. It was multiple elevator design, but it will be next article, next video probably. So if you have any questions, or if you have any suggestions, or if you want to contact me, just write comments and just below the video on YouTube. Go to my blog, contact me if you want some special article or special video to be done by me. Let me know. I'll try to do it for you. And just committing in memory database tests and that's all. Committing, and see you later.